Hello, everyone. Welcome to Wind Down Friday. Today, our special guest is James Walker, NanoNuclear CEO. Hi, James. Welcome aboard. How are you? How is it going?
Hi Maurizio, I'm not doing too badly. Thanks very much for having me on.
Thank you. Thank you. Where are you located?
So the head office of our company is in New York, but I'm actually in Vancouver in Canada today.
Nice. So thanks a lot for being here, James. So I have a couple of questions to share with you. I know that you have extensive experience in engineering and project management, in particular for nuclear engineering, mining engineering, mechanical construction, manufacturing, infrastructure, safety management, and so on. So, what recent technological advancements in nuclear engineering are you most excited about? So tell us more.
All right. I know it's going to sound biased, but I think what we're doing within the company is what I'm most excited about. Like the possibility of designing reactors that are so small that they can be transported anywhere in the world by road or by rail, and shipped to locations they've never been before. So whether that's military bases or island communities or remote industry or mining projects, um, you know, all of these kind of areas where diesel generators have been before and they've had no competition from other energy sources. And now for the first time, there'll be um, there'll be a nuclear reactor inside an ISO container that can ship into these areas and be put
Mhm.
down and plugged in and start outputting consistent high capacity factor power. Um, and this opens up all sorts of possibilities. Like for instance, we were recently in Rwanda, and we were working with the government there to um, develop their nuclear industry. And they said 60% of our population has access to consistent power. So if you're looking to deploy these sort of microreactors to remote locations, that means you can suddenly introduce things like desalination, vertical farms, industry in all of these remote locations, and you can be away from the grid. So that means a big increase in the quality of life for a lot of people, especially in these remote locations. So that's pretty exciting. So like obviously the power system is great,
Yeah.
but like the benefits that it could bring a lot of local communities are huge too. So obviously I'm very excited about that, and obviously that's it's partly why I'm doing this. And if
Nice.
I was to talk about other things that I think within the industry are very exciting, I still think the small modular reactors, which are much larger systems than the one we're producing, are still very exciting things because it basically will reduce a lot of the upfront capital costs, which will reduce the financing costs and the time to deployment. So
Mhm.
big systems can be deployed faster and more cheaply. And I believe that once there is that economy of scale, then our energy bills will come down. Not to mention that this is a clean, consistent form of energy, and you've got guaranteed power for 20, 30, 40 years, whatever it is, depending on the system. I mean, that's pretty great. That's pretty terrific.
Thank you. So, as the philosophy of Wind Down Friday, I would like to know more also about you outside your job. So let me jump on outside of your job, and then we can back in terms of technology. So outside your job, can you share some of your hobbies, how they help to unwind from your demanding career, how to stay relaxed, maybe with a good wine, play tennis,
Yes.
football.
Well, good wine never hurt anyone. Um, but I would say where I am at the moment in Vancouver, for instance, it's got some beautiful mountains, and
Yes.
like the hiking here is fantastic. I would say maybe the best in the world. That might offend a lot of people, but like it's really beautiful. I would say that's a major hobby of mine. And I try a couple evenings every week where me and my wife will go to the gym and we'll put the children in the YMCA childcare. And we'll
Mm.
just have a couple of hours of just us trying to do some exercise to try and physically unwind a little bit. That happens. I would say the funny thing is that before you have children, it's um, you have way more time to do a lot of things. So whether that's mountain biking or skiing, But now it seems that when I go home at the weekend, I just have children that I take to parks. So I would say it's become a hobby of mine just to take the children places, whether that's the pool or the sea or just like nearby parks or anything like that. So I would say that does help you unwind. It still does help you unwind doing that kind of thing. So it just you get relegated as a person and they they take priority. So yeah.
Great. So back in terms of technology, so managing large scale projects, for sure, this requires skill and precision. So tell us what strategies do you use to ensure everything stays on schedule? Because this is important, I guess.
Yeah. So I mean, there are obviously a number of software programs you can use to map out tasks, follow progress, assign things like that. I would actually say that that kind of thing is less important than who you have on your team. And they need to be abreast of the overall picture. If you do that, then and you don't micromanage, then you can actually keep large projects on track because it's it's one thing to work at a specific task, but if it's a goal that everyone is working towards, that usually has much better results. So I would say the priority is actually who you have on your team. Obviously, they've got to be the right people and they've got to know what they're doing, of course. But if you are communicating them a shared goal that you're all working towards and you're allocating tasks, the tasks get done in a much better way than if you were just assigning different tasks to individuals to complete that then you would take and feed into the overall project strategy. So I would say that that is precedence over any sort of software that tracks development or tasks or timing like that. And of course, like obviously, just to have the accountant involved as well to keep you in line with the grant budget and keep the staff in line with the grant budget is obviously very important. But yeah, people is number one, like always.
Great. So handling nuclear waste. This is a critical aspect of your work. So what are the most significant challenges you face in this area, this field?
So it's interesting because here in the US, they invested a huge amount of money, billions of dollars, in fact, into a project called Yucca Mountain, which is supposed to be a long-term storage facility. But it was a very politically untenable idea. And so they essentially scrapped it, and those billions of dollars were essentially not wasted, but lost. And that sort of left the US without a long-term storage, waste storage facility solution. So what they've sort of come to the conclusion is that interim storage facilities carry less I don't know, political controversies, for example. But the way these things are stored is that there's still no reason why it ever has to be moved. So say you concrete the thing and you put it into a location, it's it's relatively inert and it could stay in those sort of situations for a long time. So I would say certainly with the storage of the nuclear waste has never been an issue. I would say with the new generation of reactors that are using a higher grade of fuel, the issue becomes how you defuel a reactor and you move the waste fuel to an interim storage facility. So there's a number of companies. I think NEC International is one of them that is developing cask systems that can then move waste fuel at the higher enrichment levels, so that sort of HALEU levels. So the transportation of the waste is probably going to be taken care of. What I think we are discussing with the regulator currently, and the regulator is examining, is that a lot of these new designs that are coming out that are much smaller, they're looking at being able to ship a fully fueled reactor. So that's the first. So that obviously will help you a lot when it comes to the other end. You don't need to deploy a reactor, set it down, and then fuel it at site. And so that saves an enormous number of areas. But the area that's not been examined as much is at the termination of the operational lifetime of that reactor, what you do with the spent fuel, because at that point, it's a very different beast because fission products that are built up in the reactor essentially classifies as spent fuel. And the regulations around moving a fully fueled reactor won't apply to it. So one of the things, obviously, I'm interested to see whether certain allowances get made that a fully fueled spent reactor can then also be moved by road. And say that doesn't happen, you're going to then need to examine how you defuel at site in sort of remote locations. So we've been examining that, and I would say we want to examine that just in case the regulator does not amend the licensing framework to allow for the movement of a reactor that has spent fuel in it. So that is a significant challenge, I would say, that we're planning for at the moment. And we're trying to make design considerations around the ability to easily defuel at site and move the reactor. If we were to be able to do that, then the reactor would be an empty vessel, essentially, just like a tin can. And it would sit there in one place, and after a few months or a few months to a year, it would essentially be scrap metal and it could be scrapped. And we would move the waste product to an interim storage facility site here in the US.
Thank you, James. So just the last one for the final remark, looking forward. So what new technologies or new method in nuclear waste management excite you the most? But in particular, how do you see the future of nuclear energy evolving if we see in particular the rise of renewable energy sources?
So one thing in terms of future technologies with regard to waste management, one thing that gets discussed a lot is the ability to be able to use laser technologies to be able to separate certain isotopes. Now, if you do that actually, and you can separate fission products, then essentially you almost have new fuel again, because say in a microreactor, it operates for 20 years, but the burn up of the actual fuel is less than 1%. So 99% of that fuel could be used again, but it can't be used again currently because of the fission product buildup within that fuel plate. Now, if you had a waste management system that could separate certain isotopes and fission products from that fuel, then you could just reuse it. So suddenly the fuel that goes into one microreactor that works for 20 years could then be used for, I don't know, like 200 years. It would just go for that long. Or actually much longer than that. So that's obviously a very exciting development, and I hope that the technical challenges around that ability to be able to separate waste effectively comes to fruition, because then not only would you have, I mean, you already have very little waste in nuclear energy, but if you would have even less, and then you would have fresh fuel, I mean, that would be terrific. So, and that sort of leads into the future of nuclear technology. So, I mean, that's one big aspect that would benefit not just our company, but the whole nuclear industry in general. Because actually you could go into previous waste, previous spent fuel is just in storage currently, and then you'd have thousands of years of free, essentially, fuel for power. So that would be obviously terrific. I would say the how do I see the future of nuclear energy evolving? I would say certainly the deployment of smaller systems is going to become a lot more common. And in the past, we saw obviously a lot of test reactors being deployed to universities and things like that. And everyone almost forgets that microreactors have been deployed before, but only obviously at an academic level. But I think it's going to become much more common to see these things in remote locations. So if it's a mining project, whether that's concentrating ore, or if you're on an island community that currently powers yourself by diesel and it relies on a daily importation of diesel, suddenly you do have a consistent power, and you're not going to be exposed to blackouts and things like that. I think that's going to be a big aspect to it. And the other big change in nuclear is going to come from the fact that industry is very interested in it currently, because it has big energy requirements, and particularly the tech centers, data centers, AI centers, they're becoming increasingly energy hungry. And the problem with almost anything else is that it's very locationally dependent. So you say you want to put your data center in, I don't know, the Nevada desert. Well, do you run transmission lines from the nearest big grid? And if you do that, that's incredibly expensive, and they might not have enough power for you. And you can't just site wind and solar or geothermal or wherever you want. They have to be optimized for those conditions. But nuclear, you can put wherever you want and have a consistent form of power. So the tech centers and the tech industry are sort of settled on nuclear as being the solution to their energy requirements. So you're going to see a lot of nuclear power paired with big industry for the first time, where reactors are deployed specifically for chemical plants, tech centers, AI centers, rather than feeding grid systems. So I think that's going to be a big thing. And how that fits in with renewables, I think renewables will continue to become, other renewables other than nuclear will continue to become a bigger proportion of the overall market. But I think the potential for nuclear is larger. And the benefit of it is that it's a technology we know works, has very little waste, it's incredibly safe. And you know, it's already emerging onto the scene in these new forms, and it has this versatility that the other forms don't have. So it's going to be a very different mosaic of power in the future.
Great. Thank you, James. So thanks a lot for joining us. Talk soon. See you next in some conferences. Have a great weekend. Thank you.
Thank you, Maurizio. Thanks very much for having me on.